Question 10. We've got this diagram here that shows the curve of y equals 1 plus x plus 5 times root x, and the straight line y minus 3x equals to 3. And the curve and the line intersect at the points A and B. And the lines BC and AD are perpendicular to the x-axis. So for part 1, using the substitution u squared equals x, or otherwise, we need to find the coordinates of A and B. So firstly, we'll write that equation of the straight line y minus 3x equals 3 as y is equal to 3 plus 3x. And now we can set that 3 plus 3x equal to 1 plus x plus 5 times root x. So we'll write that down. So we're going to get 3 plus 3x is equal to 1 plus x plus 5 times root x. So now we're going to make use of that substitution. U squared is equal to x, which means u is equal to the square root of x. And we're just going to take the positive square root of x because we're trying to find those coordinates A and B. And as we can see from the diagram, they are both greater than 0. So we just need the positive square root of x. So substituting into our equation then, we're going to get 3 plus 3 times u squared, as u squared is x, and that's going to equal 1 plus u squared plus 5 times u, as u is equal to square root of x. So simplifying this then, we're going to get 2u squared minus 5u plus 2 is equal to 0. So now we need to solve this for u. So we could just use the quadratic formula here to solve for u, but this one does actually factorize. And it's not too bad to factorize just by inspection, but I will go through the process of factorizing it here. So what we're looking for then is two numbers that multiply together to give 4, that's that 2 times 2 is 4, and add together to give minus 5. So that's going to be minus 4 and minus 1. So we can write our equation then as 2u squared minus 4u minus u plus 2 is equal to 0. So we get 2u brackets u minus 2 minus brackets u minus 2 is equal to 0. And then factorizing that left hand side fully, we're going to get 2u minus 1 all in brackets times u minus 2, and that is equal to 0. So that means then that we either have 2u minus 1 equal to 0 or u minus 2 equal to 0. So if 2u minus 1 is equal to 0, then we have u is equal to a half, and that means then, well, x is equal to u squared, so x is going to be equal to 1 over 2 squared, which is equal to 1 over 4, or we have u minus 2 equals 0, which means u is equal to 2, and that means then that x is going to be equal to 2 squared, which is equal to 4. So we've got then our x coordinates for our points of intersection A and B, and as we can see from the diagram, A is going to be the smaller x value, so the x coordinate for A is going to be 1 over 4, and we just need to work out then what is the y coordinate there. So we can plug that value, x equals 1 over 4, into any of the equations for y we've got. So I'm just going to plug it into this equation here, y equals 3 plus 3x. So we have then, when x is equal to 1 over 4, then y is equal to 3 plus 3 times 1 over 4. So that's just going to equal 3 plus 3/4, which is just 3 3/4, or we could write that as 3.75. So our coordinates of A then, well, that's going to be 1/4 or 0.25, so 0.25, and the y coordinate is 3.75. Okay, so now to find the coordinates of B, well, that's when x is equal to 4. So when x is equal to 4, y is equal to 3 plus 3 times 4. So 3 times 4 is 12 plus 3, and that is equal to 15. So that means our coordinates of B then is going to be 4, and the y coordinate is 15. Okay, so that is question 10 part 1. For question 10 part 2, we need to find the area of the shaded region. So one way to do that is we could find the area under the curve of 1 plus x plus 5 root x. So we can do that by integration, and then we can find the area of this trapezium here, which I'm just highlighting the edges in yellow. We can find the area actually without integrating, and then we'd subtract the area of that trapezium from the area under that curve, y equals 1 plus x plus 5 root x. But seeing as we have to integrate anyway, we're going to solve this problem by taking the difference of two integrals. So our larger function, the function that is greater on this interval, is the y equals 1 plus x plus 5 root x. So we work that integral out, and then we subtract the integral of the lower function, which is y equals 3 plus 3x. Okay, so we'll write that out. So we have then the integral going from 0.25 up to 4. So those limits of integration is just the x coordinates of where those two curves intersect. So that was at the points A and B respectively. So then our integrand, which is just the part inside the integral, is going to be 1 plus x plus 5 times root x, and we integrate that with respect to x, and then we subtract the area under that line y equals 3 plus 3x. So that is just the integral going from 0.25 up to 4, and the integrand is 3 plus 3x, and we take that integral with respect to x. So we can write this out under one integral sign just to simplify things a bit. So that is going to equal then the integral going from 0.25 to 4. So 1 minus 3 is minus 2, x minus 3x is minus 2x, and then we have our plus 5 times root x, and we take that integral with respect to x. Working this out then, that integral is going to equal minus 2x, then minus 2x squared over 2 plus 5 times, well, square root of x is the same as x to the power of a half, so add 1 to the power, we'll get x to the power of 3 over 2, and then divide by the new power, which is 3 over 2. And we're going from x equals 0.25 up to x equals 4. So we'll just tidy that up a little bit. So we're going to get minus 2x minus x squared, and then plus, well, for this term here, this 5 times x to the power of 3 over 2 over 3 over 2, if we times the numerator and denominator by 2, we'll cancel out that 2 there in the denominator. So then we're going to get 10 times x to the power of 3 over 2 over 3. And we'll put our limits in there, going from 0.25 up to 4. So substituting our upper limit in first then, so we have, well, negative 2 times 4 is negative 8, and then well, x squared, so we have 4, so 4 squared is 16, so we're going to get minus 16, and then plus, well, x to the power of 3 over 2, if we put 4 in there, we can work out 4 to the half, which is going to be 2, and then 2 cubed is 8, so 10 times 8 is going to be 80, and then we have that over 3, and then we're going to subtract, now we plug in the 0.25, so we have then negative 2 times 0.25, and I'll just think of that 0.25 as 1 over 4, just so I'll keep everything in fractions. So negative 2 times 1 over 4, well, that's just negative a half, and then we're going to minus x squared, so 1 over 4 all squared is going to be 1 over 16, and then we're going to have 10 over 3 times 1 over 4 to the power of 3 over 2. So 1 over 4 to the power of a half is 1 over 2, and then 1 over 2 all cubed is 1 over 8. So 10 over 3 times 1 over 8 is going to be 10 over 24. So now we'll get our calculator and we'll work this out. So we've got negative 8 minus 16 plus 80 over 3. So that equals 8 over 3. And then we're going to subtract and make sure we use brackets here. Negative 1 over 2 minus 1 over 16, and then plus 10 over 24, and close the brackets, and that equals 45 over 16, so equals 45 over 16, and that equals 2.8125, and just rounding that to 3 significant figures, we get 2.81, and it is an area, so we can say that that is going to be units squared, and we've rounded that to 3 significant figures. Okay, so that is question 10.